Hello and welcome to this video from Heybridge High School Maths Department. This is the first of two videos to accompany Unit GM10 Objective 5. This video will look at solving complex geometric problems. So first of all, we're going to have a look at a bit of three-dimensional Pythagoras and trigonometry. So the diagram represents a cuboid. And we're given that AB is 5 centimetres, BC is 7 centimetres and AE is 3 centimetres. And we want to calculate the length of AG correct to three significant figures. So I want to find that line that is marked. I'm going to start off by finding AC. And to do that, I'm going to use Pythagoras Theorem. So AC is the hypotenuse of a right angled triangle. So I can say that AC squared will equal AB squared, which is 5 squared, plus BC squared, which is 7 squared, and that will give me 74. So I can find AC by finding the square root of 74. And I'm just going to leave that in surd form because it's more precise, it's more accurate, and I haven't got to write out lots and lots of figures in my next calculation. So now that I know AC, I now have this triangle. Just do a little sketch. AGC, and that's a right angle triangle. And I know AC, and I know that GC is 3 centimetres. Because it's going to be the same length as AE. So AG again will be the hypotenuse of a right angled triangle. So I can say that AG squared will be AC squared, which will be root 74 squared, plus GC squared, which will be 3 squared. And that will give me 83. So therefore AG will be the square root of 83, and we're asked for this to three significant figures. So AG is 9.11 centimetres to three significant figures. Now part B, calculate the size of the angle between AG and the face ABCD. So when I have something like this, I like to do again a little sketch of my triangle. So I've got A, C and G, and I've got 3 centimetres there, and I'm going to put in the exact values. So I've got root 83 centimetres for my hypotenuse and root 74 centimetres for AC. And I want to find this angle. This is the angle here between AG and the base ABCD. So if I'm going to mark this angle as X. So this side is opposite the angle, this is adjacent to the angle, and this is the hypotenuse. So it's a right angle triangle. So I'm going to use trig ratios, I'm going to use SOHCAHTOA, and I'm going to go with sine. I'm going to use opposite and hypotenuse. So I'm going to say sine x will be equal to opposite, which is 3 centimetres, over hypotenuse, which is root 83. So therefore x will be sine inverse 3 over root 83. So x will be 19.2 degrees to 1 decimal place. So now we've got a question about vectors. So we're given that OABC is a parallelogram and P is the point on AC such that AP equals 2/3 AC. So this is going to be 2/3 of the length, and this is going to be 1/3 of the length. And we're given that OA is 6A and OC is 6C. So we want to find OP. So we're going to have to find AC to begin with. So let's have a look at AC. So how can I get from A to C? Well, I'm going to go from A to O, which will be minus 6A, because I'm going against the direction of the vector. Then I'm going to go from O to C, which will be 6C. So my vector A to C is going to be negative 6A plus 6C. Now I can use that to find PC. Because in order to go from O to P, I'm going to go from O to C and then from C to P. So let's find PC to begin with. So PC is going to be 1/3 of AC. So it's going to be 1/3 of minus 6A add 6C. And that's going to give me negative 2A plus 2C. Now I'm going to go from O to P. So I'm going to go OC, which is 6C. And then I need to do CP. So I've got PC. So CP will just be the negative of 2A plus 2C. So I'm going to have 6C plus negative 2A plus minus negative 2A plus 2C. That's going to give me 6C plus 2A minus 2C. So my vector O to P is going to be 2A plus 4C. So the midpoint of CB is M. So let's kind of mark that on there. Prove that OPM is a straight line. Okay, so OA and CB are the parallel sides of a parallelogram, so they're going to be parallel vectors. So the whole of that vector will be 6A. So that means that C to M will be 3A. Now what I need to do to prove that OPM is a straight line is to show that OP and PM are parallel vectors, which means that they will have the same gradient. And since they're sort of running between 3 points, then that would also show us that they're a straight line. So I know what OP is, so I now need to find P to M. So I'm going to go P to C, which I found here. So that's negative 2A plus 2C. And then I also need to go C to M, which is 3A. And if I simplify that, negative 2A plus 3A will give me A, and then I've just got that plus 2C. And I can show that two vectors are parallel by showing that they're scalar multiples of one another. And PM is half of OP. Or we could also say that OP was equal to 2 lots of PM. So therefore we can now say that OP and PM are parallel vectors because they are scalar multiples of one another. So OPM is a straight line. So given that AB is parallel to ED, calculate the length of AB. So the first thing that we've actually got to do here is to show that these two triangles are similar. So we've got to show that ABC is similar to CDE. So if we have a look here, these two angles, ACB and ECD, are vertically opposite angles, so they will be equal. And then CDE is 40 degrees, and here we have alternate angles in parallel lines. So BAC is also going to be 40 degrees. And we have this again with angle ABC will be 80 degrees because it is vertically opposite to angle DEC. We can also do a quick bit of maths and figure this out. So we've got 40 add 80 is 120. So both of these angles are going to be 60 degrees. And now we can find the length of AB. So we can use the sine rule. So we're going to do A over sine A. So let's take 6 to be A. And the angle that's opposite it is 40 degrees. So 6 over sine 40. And then we want to find AB, and the angle that's opposite that is sine 60. And then if we rearrange that, we'll get 6 sine 60 over sine 40 is equal to AB. So AB is 8.08 centimetres, and that's to 3 significant figures. So a bit more trigonometry here. So we've got two triangular lawns. Wire fencing is needed for all 5 sides, and we need to work out the number of 50-metre rolls that we need. So we need to find this side initially. So let's call that side X. And I've got the adjacent angle. So X is adjacent to 40 degrees, and I've also got the hypotenuse. So adjacent hypotenuse, I'm going to use cosine. So I'm going to say that cos 40 degrees is equal to adjacent, which is X, over hypotenuse, which is 100. So therefore X is going to be equal to 100 times cos 40, and that's going to give me 76.60444431 metres. And I'm going to keep that whole value because I may need it later. Now I need to work out this side, Y. So Y is opposite 40 degrees, and I can use my hypotenuse again. So this time I'm going to use the sine rule. So sine 40 is equal to Y over 100. So Y equals 100 times sine 40. And that's going to give me 64.27876097 metres. Now I need to find this side, which I'm going to call Z. Now I can't use right angle trigonometry here, but I know the length of this side is 120. I know the length of Y is 64.27876097, and I've got the included angle of 30 degrees, so I can use the cosine rule. And if you remember, the cosine rule is A squared equals B squared plus C squared minus 2BC cos A. So 30 degrees is your big A. It doesn't matter which of y and 120 you take to be B and C, but you need to remember that Z is little a, because that's the side that you're trying to find. A is always the side that you're trying to find when you're using this rule. So we're going to say that Z squared is equal to 120 squared plus 64.27, etc. squared, minus 2 lots of 120 times 64.27 cos 30. And if we pop that through our calculator, we're going to get Z squared as being equal to 4,673.439442. So that would be Z squared. So Z will be equal to the square root of that. So Z is 68.36255.878 meters. Right, so we figured out Z and X. Now we need to work out the perimeter of the whole lawn. So we're going to have 120 plus 100 plus X, which is 76.6 plus Z, which is 68.3, and that will give us 365 meters approximately. So we need to know how many 50-meter rolls we're going to need. So if we do 365 divided by 50, that's going to give us 7.3. And obviously we can't buy 0.3 of a roll, so we're going to round up. So we need to buy 8 rolls. Okay, so we're given some lengths and angles here. Angle CBD isn't marked on, it's a right angle, so let's put that on as well. There's also an error here. It says angle BDE is 48 degrees. Angle BDC is actually 48 degrees. And we need to find CD. So I'm going to start off by finding BC by using Pythagoras. And because I already know the hypotenuse, I'm going to subtract the square of the shorter side from the square of the hypotenuse, which will give me 40. So BC will be root 40, and as an exact value, which is what I'm going to keep, that will be 2 root 10 centimetres. I always keep these exact third values because they're much easier and quicker to work with when you're using a calculator than trying to put great big long decimal numbers down and then put them into the calculator. So if you are confident with surds, stick with using the exact third value. So I now know that BC is 2 root 10 centimetres. And then I can use trigonometry in right angle triangles to work out the length of CD. So let's go up here so that I've got a little bit more room. So let's go with the sine rule, because 2 root 10 is opposite 48 degrees and I'm trying to find the hypotenuse, so I need to use opposite and a hypotenuse. So I'm going to have sine 48 degrees is equal to 2 root 10 over CD, and if I rearrange that, I will get CD is equal to 2 root 10 over sine 48 degrees. And that will give me 8.51, 528639. And we're asked to give our answer to 3 significant figures. So it's going to be 8.51 centimetres to 3 significant figures. Okay, now we're asked to calculate the length of CE. So we know the size of angle BDC. We also know that angle BDE is 90 degrees. So we can work out angle CDE by subtracting 48 from 90, and that will give us 42 degrees. And now we've got enough information, because we also know the length of CD, to use the cosine rule to find CE. So we're going to say that CE squared is equal to 19 squared plus 8.51. Remember to use your full answer from part A for this. Minus 2 lots of 19 times 8.51 times cos 42 degrees. So CE squared will be 193.095995. So CE is going to be the square root of that. So to 3 significant figures, CE will be 13.9 centimetres. So another Pythagoras question. This one is actually quite straightforward. So we're going to start out by finding BD. So we can say that BD squared, so AD is the hypotenuse, so we'll put that first and square it. I'm going to subtract the other side, squared, and that's going to give us 75. So BD is going to be root 75, which is 5√3 centimetres. So we now know that BD is 5√3 centimetres. And then we have BC, and that is going to be, so that is the hypotenuse, so we're going to square and add the other 2 sides, which will give us 91. I'm sorry, that should be squared. So BC is going to be equal to root 91. The answer we're asked for to 2 decimal places, so that will be 9.54 centimetres. So X is equal to 9.54 centimetres to 2 decimal places. So now we've got some angles in parallel lines, and we've got to show that triangle DGH is isosceles, and we've got to do that giving reasons. So if I have a look here at this angle of 50 degrees, just mark that in green, this angle will also be 50 degrees because these 2 angles are alternate. Okay, and alternate angles, as we know, are equal. And let's have a look here at this angle of 100 degrees. Okay, these 2 angles are supplementary because they're going to sum to 180 degrees. So that's going to be 80 degrees. So that's a supplementary angle. We could also obviously say angles on a straight line. Now we can find angle GDH. So if we do 80 add 50, that's going to give us 130. Angles in a triangle sum to 180. So that will be 50 degrees. So we can actually say now that this triangle is isosceles. This side and this side would be equal. Let's just use a different colour there. And your two base angles are 50 degrees. So what we can say here is, so let's have a look. So angle GDH and angle DHG are equal. So the triangle has two equal angles. And so is isosceles. So you just need to explain that you've got two equal angles, and a triangle that has exactly two equal angles is isosceles. Right, so our final two questions are circle theorem questions. So we've got points A, B, C are all on the circumference of the circle. O represents the centre, DA and DC are tangents to the circle, and angle CDO is 22 degrees. So if we have a look, CD and AD are going to be equal because they're both going from the same point to meet with a radius. OD is obviously common to both, and OC and OA are also going to be equal. So I've got here two congruent triangles. So that means that that angle will be 22 degrees also. Angles OAD and angles OCD will both be 90 degrees because they are formed where a tangent and a radius meet at the circumference, so they have to be 90 degrees. So we can now figure out what this angle is, because ADCO is a quadrilateral. It's actually a kite, but we know that the angles in a quadrilateral sum to 360 degrees. So if we add 44, 90 and 90, that's going to give us 224 degrees. So we can now work out this angle AOC. And that's going to be 360, because angles in a quadrilateral add up to 360, minus 224. And that's going to give us 136 degrees. Now, when you're doing this, if it asks you for reasons, you do need to write down your reasons. So you would need to be writing down your circle theorems and properties of quadrilaterals and triangles. So this is 136 degrees. Now, another circle theorem, ABC, so angle X is going to be half of 136 degrees because the angle at the circumference is half the angle at the centre subtended by the same arc. So we're going to divide that by 2, and that's going to give us 68 degrees. so x will be 68 degrees. There are other ways that you could go about this. You wouldn't necessarily need to use that kite. Once you'd worked out these angles in your triangle, you could calculate AOD and COD, add them together, and then halve and find this angle at the circumference. So with these circle theorem questions, there are often a number of different ways that you can come at them. But that is the method that I would use because it's quite quick and neat. Okay, so we're going to have a look at another circle theorem question. So I'm actually going to go through this one properly and write down my reasoning. So I'm going to start off by looking at this triangle here, OBC, and I'm going to say that triangle OBC is isosceles. And I know that because OC and OB are both radii of a circle, and a triangle formed from two radii will always be isosceles. So that means that angle OCB, so here, will also be 46 degrees. And that is because base angles of an isosceles triangle are equal. Okay, so now if we have a look at angle BAC, okay, so angle BOC. Angle BOC is going to be 88 degrees. Okay, and obviously I've worked that out because angles in a triangle sum to 180. Right, so we can then say that angle CAB is going to be 44 degrees. So now we're getting into our circle theorems. So CAB, that will be that 88 degrees, BOC, divided by 2 equals 44 degrees. And that is because the angle at the circumference is half the angle at the centre. Okay, now we also know that triangle ABC is isosceles. Because we're told in the question that AB is equal to AC. So that means that angles ACB and CBA have got to be equal. And I'm really interested in angle ACB, because that's going to help me to work out what angle CDO is. So let's work out angle ACB. So ACB would be 180 minus the 44 at CAB over 2. And that's going to give me 68 degrees. Now if I have a look at FCO. So FCO is 68 degrees. So ACB is 68 degrees. So this whole angle here is 68 degrees. And we know that OCB is 46 degrees. So if we find the difference between the two, we'll be able to find FCO. So FCO is going to be 68 minus 46, which is 22 degrees. Now we can find angle CFD. That will just be 180 minus 107, which will give me 73 degrees. And that would be because angles on a straight line sum to 180 degrees. And then here, DCO is 90 degrees. So that whole angle there is 90 degrees. And that's because DCE is a tangent and it meets the radius OC at the circumference, and where those two meet at the circumference it forms a right angle. So we can now find angle FCD. I'm running out of space here, so you'll have to bear with me. So FCD will be 90 minus 22, and that will give us 68. And then, because the angles in a triangle add up to 180, we can find CDO by doing 180, take away the 73 and the 68 that we already know, and that will give us 39 degrees. And that again is angles in a triangle sum to 180. So all that working out, and we found out that angle CDO is 39 degrees. There would be other ways of approaching this problem, but that was the approach that looked most straightforward to me. So thank you for watching.